we're going to pick up with variables and assignment. And assignment is when we take a value and we associate a name to it. And this is a very important concept in computer science because it allows us to then manipulate those values by working with the names instead of the values themselves. So let's start with a simple example of basic assignment. So we have a name, Harry, and what we're saying is we're going to create an association between Harry and the string under the cabinet. And we know that Harry is a name and under the cabinet is a string because the string is differentiated by having quotes on either side of it. Now, the way to think about what's happening here, or a way to think about it, is that we have a table and the interpreter is maintaining information about names and their values in a table. So in this case, we take Harry and we put it in the name column, and we take the string under the cabinet and we put it in the value column. And we can repeat with Hermione and with the string Muggle parents, and because Hermione doesn't exist in the table, we add her name to the table and then we put the value under the value line. So now we have two names and two values in memory. So then we add the name Ron and we assign the value Big Family. So now we have three names in the table. Now, if we decide that we want to add Ginny as another name in our memory, we want Ginny to have the same value as Ron. So we can write the assignment that Ginny gets assigned the value of Ron. Now the question is, what is the value of Ron? And the way we figure this out is we go look at our table, and Ron exists as a name in the table, and it has the value Big Family. And so when we're trying to decide what is the value of the right side of the assignment, we look up the name Ron, and we replace that name with the value, which means the string Big Family, and then the string Big Family gets copied into a new entry in the symbol table called Ginny. So after these 4 lines of code, we see 4 names, Harry, Hermione, Ron, and Ginny, and we see 4 values. And notice there's not really an association between Ginny and Ron, the names. Instead, we simply assigned Ginny the same value that Ron had at that line of code. Now, one important concept in reading code is that order matters. So for example, consider if I took the assignment to Ron and I put it after the assignment to Ginny. In this case, when I get to the line Ginny gets assigned the value Ron, the computer is going to look in the symbol table for the name Ron, but there is no name Ron in the table at that line of code. And so the interpreter will return an undefined name error in that case, and my code will stop executing. So it's important that we put the definition of Ron before we use it on the right side of an assignment, and then the computer will know what the value of Ron is when we try and assign its value to the variable Ginny. Forward in the story to when our 4 students are learning their first spell, Wingardium Leviosa. And I seem to remember that Harry took a while to learn his spell. So let's say he took 10 tries before he learned the spell. Now the question is, we're using the same name on the left side that already exists in our table. And one way, and the question is, are we creating a new line in our table? Well, that would actually make it very difficult for the interpreter to know what the value of Harry was, because if there are 2 instances of Harry in the table, then when I use Harry in a later expression, the computer won't necessarily know which value to use. And so that creates ambiguity, and ambiguity is bad when we're writing code. So instead, we want to update the existing value of Harry, and so we're changing the association, and when we make the assignment of 10 to the name Harry, we update the value in the table. And now I have a situation where I'm using the name Harry on both sides of my assignment, because maybe I remembered, oh, Harry actually had to take 1 more try before he learned the spell. So the way to think about this is we always figure out the value of the right side before we update the value of the name on the left side. And when we're looking at the value on the right side, we'd look at the current value in our table. So we go to our table and we identify the name Harry, and then we replace it with the value, the current value of Harry, and then that gives us an expression, and now we want to assign the value 11 to the name Harry, and so we update our table. And so after executing these two lines of code, Harry now has the updated value of 11. And by following that process, it's always very clear what that updated value is going to be. Now, Hermione obviously learns to spell very quickly, and so we update her location in the symbol table. Ron learns it a little faster than Harry, and so again, we look at the current value of Harry, which is 11, subtract off 2, and then we use that updated value of 9 to replace the existing value of Ron. So now, finally, we have Ginny, who takes just one more try than Hermione, and so we replace Hermione with the value 1, add those together, and then update the value of Ginny. So after all of this code, we have new values in our symbol table, and if we want to then compute the total number of tries for all of our students, we can now use the values in our symbol table to discover what that's going to be. So we replace Harry with 11, Hermione with 1, Ron with 9, and Ginny with 2, and then the computer computes that sum. We get 23, and now total is a new name, so it gets added to our symbol table with the value 23. And what this lets us do is if we then want to print that total out to the user, we know that it's going to print 23 because we've done this evaluating of all the values of the variables. We've walked through the code linearly, and at the end we can predict what the program is going to do. So the main concepts for this video are that we have to remember that code executes in a linear order, that assignment associates a value with a name, that when we assign a value to a new name, this creates a new association, but when we assign a value to an existing name, it updates the association and replaces the old value. That the right side of an assignment is always evaluated first using the existing information in a table, and that the value of the right side is copied into the location associated with the name on the left side. So if we keep these rules in mind, we can always predict what a series of assignments is going to do and how the computer will view memory when the code is finished executing.